So in today's video, guys, we're going to be doing part C or part 3, okay? And basically, we're going to talk about the last few slides. So we're going to advance to, I think it's like slide 16 or 17. Okay, so in this section, we're going to talk about natural base, which is the letter E, and we're going to talk about compound interest, okay? And we're going to have this N value. So before we talk about the natural base, let's just talk about interest. When you put money in a bank, you're going to put some set amount in a bank. We call that set amount your initial deposit or your initial amount. We call it the principal, and we identify it using the variable P. The formula for how much money you earn after a certain period of time, this future value for your money, A, is represented by this equation here. P times 1 plus R over N, all raised, or that parentheses raised to the N times T power. Well, first of all, P again is the initial amount or the deposit that you put in the bank. T represents the time in years that your money is in the bank. R represents the interest rate that you earn on your money, but it is listed in decimal form, not as a percent. N is the number of times a year that it is compounded. In other words, it's the number of times that you earn interest in a year. So this N value represents your compound interest. So let's say that you get paid semi-annually. Well, that means twice a year, so N would be 2. Or let's say that you get paid quarterly. Well, then N would be 4 because there's 4 quarters in a year. Or monthly, guess what? That would be N equals 12 because there's 12 months in a year. You could go even to daily, and that would be 365. So you could get, your interest could be compounded on a regular basis, even more frequent than daily. But as that number increases, as the number of times that you get paid the compound interest grows towards infinity, look at this equation here, as N approaches infinity, if I was to take that formula, 1 plus 1 over N to the N power, as this grows, the value approaches 2.718 or whatever, which we have deemed and called E. So I'm not going to get in too much, but basically when there is something called continuous compounding, where it's almost close to like an infinite number of times, we use a different formula. We're going to talk about that in another slide, but the different formula is going to include the letter E, okay? So just know that E comes in for continuous compounding. The other formula, this formula here, is going to be used when N has a very specific value, and it'll be given to you in the problem. So if you have a problem like this and it says you invest $12,000, well, that's your principal, at an annual rate of 3%, which is 0.03 as a decimal. That's my interest rate. My balance after 5 years, that means T is 5. And compounded quarterly, that means N is 4. Then I'm able to find the value of that investment after 5 years. It's going to be, again, the principal times 1 plus R over N to the NT power. So the amount is going to be 12,000 times 1 plus 0.03 over N of 4 to the 4 times 5 power. Now, how I would work this out on my calculator is I would start with the 0.03 divided by 4. I would do that on my calculator and I would get my amount. Without taking it out of my calculator, without rounding it, without doing anything, I would at that point add 1 to it. So again, you're going to do on your calculator 0.03 divided by 4. You're going to get like 0.0075. You're going to add 1 to that. You're going to get 1.0075. Then you're going to raise that. You're going to raise that amount to the 4 times 5 power, which is 20. So you're going to raise it to the 20th power. You're going to end up with like 1.16 and this long number. And then you're just going to times it by 12,000. The last thing you're going to do is multiply it by the principal. And since we're talking about money, I'm going to round to the nearest hundredth. So there you go. That's how much money I'm going to have in the account 5 years later at that interest rate compounded quarterly. The second example is the same concept. P is still 12,000. My rate is still 0.03. My balance, my T is still 5. The only difference is my compounding is 12. So again, I'm going to have 12,000, 1 plus 0.03 divided by 12, and I'm going to raise it to the 12 times 5 power. So if I'm going to compound it more often, then I know my ending value should be a little bit higher. And it might not be significantly higher. However, as the years go by, as T grows, the difference becomes more obvious. So I'm going to raise it to like the 60th power. So let me see. So I do 0.03 divided by 12. I get 0.0025. I add 1 to it. Then I'm going to raise that amount to the 60th power. And then I'm going to take that value and I'm going to multiply it by 12,000. And so I get $13,939.40. So not a big difference in 5 years, but a difference all the same. Now, when I go to this one, it says it's compounded continuously. And then I know that I'm using this one. The amount is, the future value is equal to PERT, okay? And what it is, it's principal, P, okay? P times the letter E to the RT power, okay? Now, notice the only thing being raised to the RT power is the E, not the P, okay? So you got to remember that. And there's E, you can find that in your calculator. So in this problem, again, you invest $12,000, so P is 12,000. That doesn't change. R is still 0.03. T is still 5, right? And it says compounded continuously. And so you know that the formula you're going to use is not going to involve N anymore. It's going to be principal times E to the RT power. RT. Okay, so this is going to be P times E, and 0.05 times, or no, sorry, 0.03 times 5. Oh my gosh, 0.03 times 5 is 0.15. So you're going to go to your calculator, right? You're going to do 12,000 times E to the 0.15 power. When I do E to the 0.15 power, I get something like 1.16 something, and then I'm going to multiply that by 12,000. Again, last thing I do is multiply by my principal. So 13,942.01. And that's the answer. So again, just know your formulas, memorize them, and know how to plug into them, and you have got this third section completely good. You're good to go.